So this problem is very similar to number 1. So what you're going to need to do to solve this problem is you're going to rewrite this logarithm into exponential form. So remember, you can use these arrows. So you're going to get 2 to the 5th equals 3x minus 4. So now what we need to do is we need to figure out what 2 to the 5th is. And you can use your calculator for that. Remember to do 2 and then caret 5. So that'll give you 32. So we have 32 equals 3x minus 4. And now we just need to work on solving for x. So we're going to go ahead and add 4 to both sides. And after we add 4, we get 36 equals 3x. Once we have 36 equals 3x, we're going to go ahead and divide both sides by 3. And so we have 12 equals x. So that is going to be now our final answer. This tells us this formula, m equals log I over s, determines the magnitude of an earthquake, where I is the intensity of the earthquake and s is the intensity of the standard earthquake. How many times stronger is an earthquake with magnitude 12 than an earthquake with a magnitude of 5? So we have two things to compare, right? We have the magnitude of 12. And so we have m equals 12 earthquake, and we have m equals 5 earthquake. So let's plug this into the formula. So for the m equals 12 earthquake, we have 12 equals the log of the intensity of the earthquake. So we'll just call that I12 for reference, over s, which is the standard. And then here we have 5 equals the log of I5 over s. So what we're going to do now is rearrange these formulas in terms of s so that we have some basis for comparing them. So what I'm going to do is I'm going to flip this equation around so that I can rewrite it in exponential form. Because remember, log means common log, right? So it has a base of 10. So when I rewrite in exponential form, I get 10 to the 12th equals I12 over s. Here, when I rewrite this one, I'm going to go ahead and first flip it around. So I have the log of I5 over s equals 5. So just rewrite in exponential form, and I have 10 to the 5th equals I5 over s. So now what I'm going to do is I'm going to multiply both of these equations by s so that I just get 10 to the 12th s equals I12. And then here I have 10 to the 5th s equals I5. So now notice I have two expressions that tell me the intensity of these earthquakes, right? So what is it asking me? It's saying how many times stronger is an earthquake with magnitude of 12 than an earthquake with magnitude of 5? So stronger, it's asking me to compare the intensities, okay? So we're basically saying that I12 is something times the intensity of magnitude 5, right? Well, we know that I12 is equal to 10 to the 12th times s. And then we're looking for something, right? We'll just call that x. And then I5 is the intensity of the magnitude 5 earthquake. So that's 10 to the 5th s. So what we can do now is notice we have a common factor of s we can divide out of both sides. So if we divide both sides by s, that s is going to cancel. And so that's going to give us 10 to the 12th equals x times 10 to the 5th. And what we can do now is divide both sides by 10 to the 5th. And so remember, when you're dividing these, you have a common base, you just subtract the exponent. So you have 10 to the 7th equals x. So the magnitude 12, okay, is going to be 10 to the 7th, we could say is 10 to the 7 times more intense than the magnitude 5. So in this problem, it says we have $5,500 in a savings account paying 2% interest compounded continuously. In how many years will you have $12,000 in your account? So the key idea here is it says compounded continuously. So that's why we know we're going to use this formula, because this is what we use when we have compounding continuously. This is when it says something like you use the left formula when you have quarterly, monthly, daily, things like that, a specific schedule. So now let's go to this circled equation and let's plug this in to figure out when we'll have $12,000 in our account. So $12,000 is the amount that we're going to end up with. So we're going to say 12,000 equals, and then we're going to start off with P. So that's 5,500 times E to the R. Okay, so R, remember, is that 2%, but we need to convert it to a decimal. So that's going to be 0.02. So that's E to the 0.02 times T. Okay. So now remember, what we need to do is solve for t, but we need to first get that exponential term by itself. So I'm going to go ahead and divide both sides by 5,500. And when we do that, on the left side, we have 12,000 divided by 5,500. And so we get 2.1818. and that's equal to e to the 0.02 times t. Well, now since we have e, we need to do the natural log of both sides, right? That's how we get rid of e. So we do the natural log of the left side, and so that's going to give us approximately 0.78016, and that's equal to 0.02 times t. Okay, now to solve for t, all we need to do is divide both sides by 0.02. And when we divide both sides by 0.02, we end up getting 39. Okay, so it's like 39.0079, but we can just round it to 39. So we have 39 years before we'll have $12,000 in our account.